So here's the deal. Today we're going to go over lesson 4. Remember, Fridays are big tests. So for lessons 1 through 6, but lesson 6 is kind of a review, nothing new. We'll go over lesson 5 today in a little bit. Tomorrow you need a Chromebook. Friday you need a Chromebook. What if you don't have a Chromebook those days? Only time after school, and then you can't do what you're supposed to do during class. So it kind of doubles up on you. So make sure you have that done. Okay? So now, number 1 on page 39, the homework. If Joseph mows the lawn, how much money does he get paid?
Nothing.
$15. Every lawn he mows, which maybe seems unfair because are all lawns the same size? No, but he gets paid $15 no matter what. Is the amount he earned proportional? Well, if he mowed 1 lawn, how much money do you get? 15. 3 lawns, how much money does he get? $45. What depends on what in this situation? The amount of money you get or earn depends on how many lawns you mow. What if you mow 0 lawns? $0. What if you mow 20 lawns? You get paid a lot of money, 20 times 15. So again, that K value is consistent, so it is proportional. Now this next one, Caitlin saved $120 from her summer job. Okay, this was in her initial deposit to the bank. She was going to save it. Then as school year starts, she gets an allowance. She puts $5 in every week. So to start off with, she had $120. Then she has 1 week go by, she has 125. 2 weeks, 130. Does that make sense? Okay. Is this proportional? No. Why not, Carson?
Because you don't keep times in
Yeah. Yeah, 0 to 120, that's your first one. Remember we said it has to go through 0, 0, and it doesn't. But what I do to 1 to get to 125, what I do to 2 to get to 130, right? It's different numbers. So this would be not proportional, okay? It's still a relationship, but it's not a proportional relationship. Then we look at Lucas and Brianna. They read 3 different books of different sizes during last month. The table shows what they did. So now, what depends on what? Notice they switched it around. Normally, time was up top. They put down here. But remember when we did distance divided by time with our hands? This is like this. Pages read divided by how long it took you. Same thing. So time is in the denominator. Your pages that you can read depend on how long you have, right? So we look at these numbers. What would you do to find out that K value? Yeah, just divide. When you take 208 divided by 8, 156 divided by 6, 234 divided by 9, you should have gotten 26 every time, which means there is a constant proportionality. Now, what does that 26 mean? Well, Lucas read 26 pages per hour, all right? Is that pretty consistent? You bet. Now, Brianna, she read 3 different books, and when we divide those out, pages per hour, we get different numbers. All right, did she read at a consistent, constant rate? No. Now, this next question, here's the deal. If you have something down, I probably wouldn't count it wrong. Try and think of something. They're going to get questions like this all the time. Try and come up with something that is like this, that is something that makes sense, okay? And I'll probably give you credit for anything. What I think is maybe Lucas read all books that were the same exact reading level, so he read at that consistent 26 pages per hour. Whereas Brianna had different goals. She wanted to read different level books. This book might have been a little easier because she read it at a faster rate. This book might have been a little tougher because she read it at a slower rate, okay? But then again, we don't know. Maybe she should be reading much faster than that, and she's reading books that are too easy, okay? Or maybe she's reading 2 books too hard, whatever. They might be above her level, below her level. We don't know all those details. But looking at the 2, can we tell which one's maybe the better reader?
Yeah.
Which one do you think is the better reader? Maybe Brianna, because she read more pages per hour, but then again, she might have been reading easier books than she was supposed to. Okay? So, yeah, we can maybe make a guess, but do we know for sure? No. Okay? Now, our next page, and I'm trying to think, oh, good, I deleted it. I was worried that I didn't delete it. So, Isaiah, you guys know Isaiah? He's selling candy bars, trying to raise some money. It's a fundraiser. And Isaiah is trying to get some money for a scouting troop. The table shows the amount of candy he sold compared to the amount of money he received. Then we got to figure out, is the amount of candy bars sold proportional to the money Isaiah received? Now again, which one would be the dependent variable? Which one is the independent variable? X is independent. Doesn't matter how many candy bars he sells. This amount of money depends on how many he sells. Does that make sense? Your Y depends on your money that you earn depends on how many candy bars you sold. Now, what we want to do is find out that unit rates. We want to find out that K value. And what we do is take your Y, your dollars, divided by what you get. Right? Doesn't that tie to what we did? Dollars divided by what you get. So go to your calculator. What's 3 divided by 2? 1.5. Very good. Now, what does that 1.5 mean? What is a label that we would tie to 1.5? 1.5 what? Well, yeah, we're talking dollars. So dollars, now here's the deal. Dollars, we need to have dimes and we need to have pennies, cents. Okay? So we need to write it this way. It'd be $1.50 per candy bar. Does that make sense? That's our unit rate. That's what that 1.5 means. Now we need to figure out what's our unit rate for this one. When you sell $5 worth and you get 4 candy bars, 5 divided by 4 in your calculator. Jackie? Perfect, $1.25. So let's write that right there. Now, immediately we know, is this proportional? It's not proportional. So we could say, is the amount? No, it's not. Okay? No, it's not proportional. Well, let's keep finding those unit prices, so to speak, and maybe we'll have a good reason why it's not proportional. So what's 9 divided by 8? 9 divided by 8 is about 1.125. Now, here's the 1.125 would be like $1.12.50. Can we have half a penny? No. Now, here's the deal. Should you round down or should you round up? Well, rounding rules say round up, but businesses, no matter what, they round everything up. Even if it was 1.121, they'd round it up to $1.13. Why? Because they can't afford to lose half a penny every transaction. They round everything up. So this would say $1.13. Okay? And then the last one, that's pretty easy. Jackie, what'd you get? Nothing. No. What's 12 divided by 12? 1, which when multiplying it does nothing. So I understand where you get confused there. But $1. So here's the deal. Is it proportional? No. We have different rates of candy bars depending on how many you buy. And the more you buy, the better the what? The rate, the unit rate, the better the deal. Normally it's like, hey, you buy 1 candy bar, $1. Buy 10 candy bars, that's $10. Buy 100 candy bars, that's $100. They don't give you a break on the price, but Isaiah does. The more you buy, the more you can save per candy bar. Okay, so we know there are different K values, but we could say no, and he sells the candy bars at different prices. He sells candy bars at different prices. And basically, the more you buy, the better the deal. Are people more likely to buy more candy bars if you get a better deal on them? You bet. Yeah. Here's the deal. I would spend the $12 to get 12 candy bars. I would feel I'm getting ripped off if I only bought 2. But maybe I only had $5. Can I buy the 12 for 12 deal? No. If I only had $5, can I spend $12? No. Unless you let me borrow some money. So here's the maybe you're limited to that, but I'd still buy that. Okay? So, and that's like raffle tickets. Sometimes they do that. You can get 1 for $1, or you can get like 7 for $5, or you can get 20 for $10, or something like that. The more you buy, the better the deal is. Okay? So, not proportional. Now, what we're going to do is start tying in graphs. And we're going to look at what the graphs look like. And there's a specific thing that needs to occur in a graph if it is proportional. Now, let's go back. What was that original kind of equation that we used that has some letters in it?
Oh.
Something equals something. Yes, Kale.
Y equals KX.
Perfect. I know you've written it down. Let's write it down again. Y equals KX. Okay?
Write somewhere else. Somewhere else.
I would write it right there. But you can write it wherever. But we have some room there. So now, Y equals KX. What does that K stand for again? The unit rate, which we have a big fancy name for it. Could be the unit price. We also call it the blank of blank, a blankety blankety. Constant of proportionality. So that's your K value. Then we said, well, one of the variables is dependent, the other one is independent. Which variable is independent? Which variable is independent? Doesn't matter what it is, we can plug in whatever. That's the X. The Y is dependent, kind of like little babies, because they depend on what these two things are. Whatever your K value is, whatever your X is. Doesn't matter what those are. The K is always the same, it's constant. Whatever your X was, will kick out whatever the Y is. So Y depends on those two. Okay? Now, what we're going to do is turn that X and the Y into what we call coordinate pairs. Have you seen these before?
Yeah.
X comma Y. Write that down. Good review. X comma Y. Has to be that order. It's always that order. When we look at a graph, a coordinate graph, this is my X-axis going along the 0 here, and this one up here is my Y-axis. Okay? Now, it's pretty simple if you remember this little picture here. The X always refers to the left or the right movement. It's always horizontal. Now, for the most part, everything we're doing right now is positive. Later on, we'll look at where they're negative values. Okay? The Y, the second number, tells you how far up you go or how far down you go. So it's the vertical movement. Okay? So write that next to that, and that'll help you remember, Jackson, when you're doing this and you're trying to graph. Super easy, if you remember that. I remember getting confused when I was a kid, but it's not that tough. Okay? So we have horizontal. Now, does anybody remember the name of this quadrant in the whole coordinate plane? So we have this coordinate plane. We have one quadrant here. Macy, you remember the name of that? Say it again. No, the origin is 0, 0. What do we call this quadrant? Erica, you remember? Quadrant 1. Now, do we use a regular number 1? No, we use a Roman numeral. So this was quadrant 1. Over here would be quadrant 2. If we were to extend these two. Quadrant 3 is down here, and quadrant 4 would be down here. If you're in my classroom, you can turn to the back. I have a little poster. I need to make it bigger. I did this many years ago to help us remember, and I used the Star Wars movies. Episode 1 would be top right. Episode 2 is top left. Episode 3 is down right, left, and then episode 4 is down right. Which episode 4 was the one that came out when I was a kid. Then they went back and did the prequels after that. And people say, why is it that way? Why doesn't it start top left? Well, here's the deal. For your entire life, you've been using quadrant 1 because it's a positive value for X and a positive value for Y. You would count like M&Ms and put it in a bar graph. You would do some other little statistical type thing. It was always in quadrant 1. And what we do is go counterclockwise around when we count. And throughout this year, next year, future years, you're going to see more situations that show up in the other quadrants. Okay? All right. Now what we need to do, we forgot the bulk of it once I give you all the detail. What we're going to do is make it so it is proportional. So this one up here was not proportional. We're going to make this graph so it is proportional. And if you sold 2 candy bars at $3 each, what if you sold 4 candy bars? How much would he charge? 6. So you should be writing it down. So that it all fits on there. What if he sold 6 candy bars? Well, what do I do to 2 to get to 6? Times 3. So what do I need to do to 3? 3 times 3 would be 9. Then let's do 8. Well, 4 jumping 8 doubles it. What would I do to 6? That'd be 12. Okay? So now we turn this situation into proportionality where no matter how many candy bars you buy, you pay $1.50. That's what this is. Now, let's graph this now. If he sold 0 candy bars, how much money does he make? 0. That is huge right there. Then we're going to plot over to up 3. We go over 2, and we go up 3. Put a point right there. Okay? Then we're going to plot point 6, 9. We go over 6. Actually, cancel out 4, 6. I skipped that one. Go over 4, up 6. Then we'll do 6, 9. Go over 6, up 9, which gets kind of tough, especially looking on a big screen. Notice I make my dots kind of big. That helps me when I make a mistake, but if I do it wrong, let me know. And then let's do 8, 12. So we go over 8, and we go up to 12. Looks like right about there. Okay. Now, first thing was, did it go through the origin? Yes, that's important. You sell 0 candy bars, you get $0. The other thing, of all the proportional situations or relationships that we looked at, they all appear to be on a straight line. What you can do at home, take a straight line. If you have a yardstick, great. If you have a regular ruler, great. If you have a pencil, if you have a calculator that has a straight edge, or another piece of paper, an eraser, that's very good. Line it up on your paper. Does it appear that those lines are, or those points are on a line? They appear to be on a straight line? Yeah, very, very close. And again, with my big dots, it looks good, okay? If it goes through the origin and it looks to be a straight line, guess what? It's proportional. We don't have to find the K value. We can just look at the graph and determine it that way, okay? So, let's go to the next page. Next page. And they want us to now, we've got the characteristics. So what were the 2 things I said? Characteristics of graphs must go through the what? Or have a point on the what?
Origin.
Good. Must go through the origin. And what is the coordinate for that?
0,
0, 0. That's 0 left or right and 0 up or down. Must go through the origin and, which that's my and symbol. You might do a different and symbol, doesn't matter. Whatever you do, whatever they taught you for and, that's what they taught me. And what does the points need to appear to be on?
Straight line.
You bet. Must go through the origin and be a straight line. Okay? 2 things. That's all you got to check when you're looking at a graph. If it doesn't go through the origin, guess what? Not proportional. If it doesn't appear to be a straight line, guess what?
not proportional.
Not proportional. So now we're going back to the original numbers. Let's graph these coordinate pairs. Again, this tells me my left or right. Well, that's a horrible arrow. I apologize. And this tells me my up or down. Okay? So we go over 2, up 3. Go ahead and do them at your own pace. It is super tough doing it on the big screen. I think that's right. Okay, now, honestly, looking at it from here, does it look like they're on a straight line?
No. Yeah.
I think it looks pretty good. Looks like a straight line, but when we take our straight edge and we go through, what was the other point we should have plotted? 0, 0. So if I put my ruler up there, it goes through 0, 0, and there, does it go through the other points?
No.
No. If I do 0, 0, and I do the second point, does it go through the other points? No. So it kind of curves off a little bit, but it's not a straight line, okay? And you can prove that with those different methods. So is this a proportional relationship?
No.
No. And again, we can look at the graph. We don't have to look at the K value. You don't have to find the K values. You can just say, not a straight line, not proportional, okay? This next one, let's have you plot this one. These X and Y. So plot those points. And actually do through 9. I'm going to just do through 9. We don't have to do the last one. So 0, 3, 6, 9. Where's 9?
In between.
You bet, yeah, in between there, do the best you can right in between there. Nine, 15, so we go over 9, up, 15. Does this appear to be a straight line?
Yeah, no.
Use a straight edge, use your pencil, use your pen. Use an eraser. Does it appear to be a straight line? I'd say yes. I use my yardstick on here, I go through there. So that one checks, but what happens, Xander? Yeah, so it doesn't go through through the origin. Xander's totally correct. So is that a proportional situation?
Nope.
No. Kind of like the example where the girls start off with $120, where the kid had 15 toy cars on his birthday. It is not a proportional situation. That is a relationship, but it's not proportional. Okay? So now the summary, when two proportional quantities are graphed on a coordinate plane, the points appear to be on a line that passes through the origin. Very important. Let's look at these real quick, the exit tickets. Imagine what these points look like. I go over 1, up 3. I go over 7, up 1. I go over 4, up 2. Am I doing the same thing to each of these numbers to get to the y? No, those points are going to be all over the place. Is it going to be proportional?
No.
No. Now this one, they say, hey, we only give you 1 point. Can you make it proportional?
Yeah.
Well, what point does it have to go through? 0, 0, so that would be 1. Okay? Then you'd go over 4, up 2. Right there. What would be the other point? Can you make up another point?
8, 4.
You bet. 8, 4. We go over 8, 4, and that would be right about there. And sure enough, that looks like a straight line. I'll tell you what, I can barely draw a straight line without dots. I cannot connect those 3 dots on this thing. I used to be able to do it on board, but I don't write on the board anymore. So, if you can draw a straight line, that'd be great. Now, your homework, I want you to jump over to the homework helper, read through it, look over it, agree with what it's saying. It's helping you, and it's tying you into what you're going to do for the homework. If you look over this first, when you get to the homework, you'll be like, oh, this is what they just did. Now I can do it on my own. Your homework is on page, I believe it's 49. Is that right? 49 onto 50. 1, 2, and then on the back side, number 3, A and B. Okay? So it's the problem set starting on page 49. Okay? Test is when? Friday. Review is tomorrow. Bring your computer.